Let's dive into Google Cloud Endpoints for REST APIs. This diagram illustrates the high-level steps to make your API backend available as Cloud Endpoints API. After you develop your REST API backend, create an API configuration file that describes your Cloud Endpoints API. Deploy the API configuration by using the gcloud service management deploy command. The gcloud command returns the service configuration ID and service name. Specify the service configuration ID and service name in your API backend's configuration file, such as the app.yaml for App Engine flexible environment deployments. Finally, deploy the API backend. Create an API configuration file that describes your Cloud Endpoints API. The API configuration is a YAML file as shown in the slide. The YAML file describes the API using the OpenAPI specification. The OpenAPI specification and its extensions enable you to describe the surface of the API and security definitions. You can specify security definitions for user authentication and service-to-service authentication. Various tools are available to help you create and manage your OpenAPI specification. See the Downloads and Resources pane for more information. When you deploy the API configuration, the configuration is registered with the Service Management API and shared with the extensible service proxy. Service Management uses the host value in your deployment configuration file to create a new Cloud Endpoint service with the name specified or shown here in this gray box. The name has the format your API name, .endpoints, .your project ID, .cloud, .goo. This API service name is created if it doesn't already exist, and then Cloud Endpoints configures the service according to your OpenAPI configuration file. Cloud Endpoints uses DNS-compatible names to uniquely identify services. Because projects in Google Cloud Platform are guaranteed to have a globally unique name, you can use your project name to create a unique API service name, such as quizapi.endpoints.myprojectid.cloud.goo. You can also map your own DNS name to your API. The extensible service proxy is an Nginx-based proxy that runs in front of the API backend and injects Cloud Endpoints functionality such as authentication, monitoring, and logging. The proxy uses techniques such as heavy caching and asynchronous calls to remain lightweight and highly performant. At runtime, Cloud Endpoints can receive calls from any source such as mobile applications, web applications, and other services. The calls are load balanced and routed to the extensible service proxy. The extensible service proxy works with the Service Control API to check the request against the API configuration and verify that the request can be passed through to the backend. If the request authenticates successfully, the extensible service proxy passes it on to the API backend. The Service Control API logs information about incoming requests. These logged messages and metrics can be viewed by using the Google Cloud Platform console. With Cloud Endpoints, you can authenticate users who are attempting to invoke your front-end APIs. With Cloud Endpoints API, you can authenticate users who are attempting to invoke your front-end APIs. Cloud Endpoints supports user authentication with Firebase, Auth0, Google Authentication, and other custom authentication methods. After the user signs in, the authentication providers send a signed JSON Web Token, also pronounced JOT, to Cloud Endpoints. Cloud Endpoints checks that the JOT is signed by the provider that you specified in your configuration file. For service-to-service authentication, create a service account. Use a Google ID token to sign the request. To restrict access to your Cloud Endpoints API, you can assign cloud identity and access management roles to specific users. You can grant access to a specific API or to the entire cloud project. To give users the ability to enable your service in their own cloud project and invoke its APIs, assign the service consumer role to them. This is the most common use case. You can assign the service controller, viewer, editor, or owner roles to give users greater permissions to view and manage service configurations and projects. You might make small changes, bug fixes, and performance enhancements to your API backend. These changes are usually backwards compatible. In such cases, it's a good practice to increment the version attribute in the Cloud Endpoints API configuration and then redeploy the API configuration and the backend. In the example shown, we've increased the version number from 1.1 to 1.2 because this is a backwards compatible change. If you make changes that are not backwards compatible and will break consumers of your API, deploy two versions of your Cloud Endpoints API by creating a separate API configuration for each version. The gcloud service management deploy command will return a different service configuration ID for each version. Update the API backend configuration of each version with a corresponding service configuration ID. In the example shown, we have different API configurations for version 1 of the API and version 2 of the API. You can also delete versions of your API when they are no longer in use. Make sure to announce your deprecation and phase out plans to the consumers of the API well in advance. This will give them time to evaluate and migrate to newer versions of your API. While developing and deploying APIs, you probably have separate environments for developing, staging, limited releases such as private alphas, and production. You can create separate projects for each environment and deploy your Cloud Endpoints API and backend with separate endpoints for your consumers. For example, developers can run their unit tests against the development environment. You can run integration tests against the staging endpoint. A separate project for private alphas provides a high degree of isolation from other environments. In the Cloud Endpoints dashboard, you can see metrics related to requests, 4xx and 5xx errors, and latency. You can also view logs in Stackdriver logging to see detailed information about requests to each API. Here are some pointers to more information. The API Design Guide is a great resource to help you learn how to design APIs in general. Also check out this talk from the Google Cloud Platform Next conference.